So, welcome to module 9.1, and we are going to the penultimate stage of the entire course, wherein we are looking at compiling the Jack language. I hope you had done a significant amount of exploration through project 9, where you got a reasonable understanding of the Jack as a language. So, some of the routines that were there, I hope you executed those programs. You also made the VM emulation. You convert it into VM using the Jack compiler that is provided as part of your tools, and actually executed the VM to find out much more interesting facts about the programming language and also the interface of the programming language with the operating system. So, with that background, assuming that background you have already got through, now we will go into the most important aspect of writing a compiler. So writing a compiler is a very interesting thing, and there are very few compiler researchers across the world, right? People who can actually hack into a compiler and basically come out with very good code for compilation, right? So understanding compiler in its full perspective is a very important aspect of any computer science and engineering curriculum. And I hope this module, module 9.1 to 9.6, will try and cover what we call as the front end of the compiler. The front end of the compiler, we will be explaining it in more detail, but to just give you a nutshell, the front end of the compiler will take the code and convert it into what we call as a parse tree, right? What is a parse tree we will be seeing. Now, in the module 10, we will go into what we call as the back end of the compiler. Probably the last module 9.6 or module 10, somewhere there, we will look at the back end of the compiler, wherein the actual code for the VM the actual VM code is generated. So, to basically get into that thing, we are now starting the attempt of taking a Jack program and converting into a VM program, a stack based VM program. Once we can convert it to that, then the remaining part we have already done. We know how to convert VM to mnemonics, and we know how convert mnemonics to binary. So, this is our next step, and associated with this module is what you call as the project 10, which basically does the front end of the compiler. So, it is called compiler 1, which is the front end, and project 11 will do the back end of the compiler. And we will be ending up the course with project 12, which will be teaching you more about the operating system interface. Okay. Of all the modules, this module is going to be pretty easy, provided you actually make a good attempt to understand what we are trying to tell. Okay. So, as the first part of this module 9, which is 9.1, we will be talking about something called tokenization. So, what is token? We will see. Now, I am basically using the slides that are available in nan2tetris.org under projects division. So, you can download the same slides and keep it for your reference. There are slides for every project that you have done, and you can continue to see that there. Okay. So, let me just so we will be doing tokenization as the first part of this entire exercise. What is tokenization? Right. If I have a program, I would love to understand what are all the different different elements of the programming language that program actually contains. For example, look at this slide. I have on the left hand side, you have if x greater than 0, then let sign equal to negative. So, this is a simple if statement. There are comments also. So, what is relevant for the compiler? First and foremost, the comment is not relevant for the compiler. So, the comment is removed. Now, what will tokenization do? It will split every small entity of the left hand side into separate lines, one entity per line. Each entity is actually called a lexical element, right? Lexical is basically associated with the syntax or grammar of your language. So what does your language basically possess here? Your language possesses what you see on the right hand side. Say if is a separate lexical element, it's a keyword. Bracket, parenthesis, open left parenthesis is a separate element. X is an identifier. It's an element of your language. Less than sign is an element of your language. 0 is again a constant. It's an element of your language. And then we have missed the close parenthesis. There should be a close parenthesis also. Then after the 0, I'm talking about the right hand side, and I'm moving the mouse there. So then the braces is one element. Let, then the comment is completely not necessary for us. Let is a statement. Let is a keyword. Sign is sign is an identifier. Equal to is a symbol, and negative, this is a string constant. And then what you see, semicolon is a separator. Again, it's a symbol. And then this closing parenthesis is also a symbol. So your program, what you call as proc.jack, that you see on the left hand side, is a stream of characters. And what essentially happens after tokenization is that every element here, every programmable entity here gets split into different lines. One programmable entity, or what we call as a lexical element, is put in every line, and you essentially each lexical element is called a token. So a stream of characters that form your Jack program essentially gets converted into a stream of tokens, right? And this is what we call as tokenization, right? Now, how do we approach this tokenization? Pretty simple. So what are the things that are part of your, what are the different tokens that you have? You could have keywords, you could have symbols, which are basically identifiers. You could have integer constants, you could have string constants, and you could have identifiers. You could have symbols. Sorry, symbols are not identifiers. Symbols are the equal to, greater than, less than, braces, etc. Then you could have integer constants, string constants, and identifiers. So there are 5 different lexical elements in your entire language of Jack. So whatever is relevant to the compiler in a program, comments are not relevant. Everything other than comments are relevant to the compiler, and every entity in that program can be mapped down to one of these 5 different heads that we have listed here. So this is what. So what are all the possible keywords? You have these time: class, constructor, function, method, field, static, var, int. Like that, there are totally 16, 18, 21 different keywords. So anywhere I am seeing, for example, in this case, as I am moving the mouse there on the top, if you see let is a keyword, I need to classify it as a keyword, right? Similarly, there are so many number of symbols: open braces, close braces, parenthesis, square brackets, plus, minus, star, tilde, etc. Okay, there are so many of them, right? And then there could be integer constants, there could be string constants. How will that string constant look like? It will start with a double quote and end with a double quote. And then I could have identifiers, which are variables, which can be a sequence of letters, digits, and underscore, but not starting with a digit. For example, X is an identifier, sign is an identifier in the top. They are all a sequence of letters, or digits, and underscore, and that sequence should not start with a number like a digit. So I could not have variables which are starting like 2x, 2x or something like that, right? So I cannot start a variable with a digit. I can always start a variable with an underscore or a alphabet, and can be forward. So this program that you see essentially has these elements. First, there is a keyword, which is if. So we need to generate this file. What is the entire aspect of tokenization is to generate this file. So we say keyword if / keyword, symbol, then one blank, then one parenthesis, another blank and symbol. Note that the parenthesis is a symbol, then X is an identifier. So, I have identifier slash identifier, then I have symbol, again less than is a symbol, then again 0 is a int constant. Actually, you should say integer constant, as you see here. In the program that you are going to write, you should get integer constant, not int constant as you see here, integer constant in full, 0 integer constant. Then symbol, then one blank, then actually that symbol, the close parenthesis, and then blank and slash symbol. So, that is what. So, the first 1, 2, 3, 4, 5, 6 entities essentially gets tokenized as this. Then the entire comment has to be neglected, it should be removed. Okay. So, then we have no, we start with the symbol less than with the braces, and then the entire comment has to be removed. Then we have identifier, and then we have a keyword let, then we have an identifier sign, then we have a symbol equal to, then we have a string constant, can't be const, it should be string constant as you see here, string constant, and so that is negative slash string constant, then you have a symbol, then you have another symbol. So, every entity, every lexical element that you see in this program gets or put into a separate line each, and then identified whether it is a keyword or a symbol or an integer constant or a string constant or identifier. So, the Jack basically has these 5 entities, right. So, this is basically your tokenization. Okay. Right. Now, so now let us see this. So, the first part of your project 10 is to do this tokenization. So, the first part of your project 10 is to basically do this tokenization, and what we will see in the next module is a demo of this tokenization. Before we go into the demo part, what we need to do as a part of writing that program for the tokenization, that also we will basically see in module 9.2. So, to sum up module 9.1, we now take the language, identify every lexical element and put it in separate lines, and classify this element as whether it is a keyword or it is a identifier, or is it a symbol, or it is an integer constant or a string constant, one of these 5. So, that is what we mean by tokenization. By tokenization, we have understood the complete every lexical element of your program is basically understood, and in addition we also understand in which sequence they are arranged, one after another. So, the sequence in which these tokens are coming and what are those tokens, and identifying of every lexical element is done as a part of the first part of your compiler, which is called tokenization. Thank you.